Hello, girls. Hope everybody's doing well. Today we're going to look at application problems. I should be back in class before the end of this block, so hopefully I can help you if you have any questions. But just to get you guys started, I made a video of the lesson. So today we're going to look at application problems with systems of equations. So if you recall, systems of equations is when you have one or more equation to solve. So they use the same variables. And we talked about there's many ways to solve a system of equations. If you recall from the quiz you all took before break, we can do graphing, we can use substitution, or we can use elimination. And those methods also apply when we're solving application problems with systems. So in theory, you could use any of these methods, but actually, you normally probably won't be graphing to solve a system of equations with application problems, but you could. Normally, we really look at substitution or elimination. And then it's just a decision about which method is best for the equations you have. So maybe if you already have a variable by itself, you might want to go ahead and use substitution. If your equations look like you would be able to eliminate one of the variables easily, you might want to use elimination. Okay, so let's just kind of jump right in and look at some examples of the types of problems we're going to see with a system of equations. So first we're told the sum of two numbers is 19. Their difference is 7. Find the numbers. So these might look a little bit like the equations or the application problems we solved in the first unit, where we were just using one variable. But all of these will require two variables, and so they will require two equations. So for this first one, we're told the sum of two numbers is 19. So we're going to let x equal the first number, and y will equal the second number. Then we look at what we're told. The sum of those two numbers is 19. So x plus y will equal 19. Their difference, meaning the subtraction, right? The difference is 7. So we can say x minus y equals 7. Now we're told to find the two numbers. Well, if you look at these two equations and the way they line up, we could use substitution. That wouldn't be that difficult. But we can also use elimination, because we can tell right here that if we added these two equations together, those y's would cancel out. So let's do that. So if we add these two equations together, we get x plus x gives us 2x. Y minus y, that cancels out. 19 plus 7 equals 26. So now if we solve 2x equals 26, we divide by 2, we get x equals 13. So one of our numbers is 13. To find y, we can substitute that into one of our equations. So I'm plugging this into the first equation, and I get y equals 6. So there I have my two answers, 13 and 6. And we can see that 13 plus 6 would equal 19, and 13 minus 6 would equal 7. Okay, so that's one example. Let's look at another. So here we have the sum of two numbers is 15. Twice their difference is 70. Find the numbers. Again, this is going to set up just like our previous one, where x will be our first number and y will be our second number. And if we look at the equations, we again have the sum of two numbers is 15. So x plus y will equal 15. Twice their difference is 70. A little bit of a twist here. Twice their difference means we have to multiply their difference by 2. So we can say their difference is x minus y, and twice that would be 2 times x minus y equals 70. Now, before we try to decide which way to solve this, we're going to want to distribute that 2. So we get 2x minus 2y equals 70. And I'm just going to go ahead and bring this equation over also. Okay. So now I could do elimination on this one, Or I could do substitution. I'm just going to go ahead and do substitution to show you guys that you don't always have to do elimination. So I'm going to get my x over here, and I'm going to say y equals 15 minus x. So now I have y equal to this expression. And I'm going to substitute that into this next equation where I see a y. So you can see I took this 15 minus x, and I put it in for y in this equation. And now I'm going to solve. I get 2x. Now I'm distributing that negative 2, so I get 2x minus 30 plus 2x equals 70. So be super careful. Some of your quizzes, some of you had some issues with distributing. So you want to make sure you take care of your signs. Now I get 4x minus 30 equals 70. I add 30 to both sides. I get 4x equals 100. I divide by 4. X equals 25. So if I get x equals 25, then when I plug that in to solve for y, I can say 20. Well, actually, I can go right up to my equation here where I see I have y equals 15 minus x. I say y equals 15 minus 25. So I get y equals negative 10. So a little bit different, but let's make sure that it makes sense. So the sum of two numbers is 15, and yes, so I'm looking up here, sum of two numbers is 15. So 25 plus negative 10 would give us 15, and twice their difference is 70. So if I look at their difference, if I take 25 minus negative 10, I get 25 plus 10 is 35. So that's their difference. If I multiply that by 2, I get 70. So yeah, that seemed a little tricky with getting a negative number, but it all works out. So my answer is 25 and negative 10. Okay. All right, so that's one type of problem where you're just solving for numbers. And when that happens, again, you want to set up your variables just with x being one number, y being the second number, and then finding your equations. Okay. Now we're going to go into another type of problem. So this one says you bought a total of 6 pens and pencils for $4. Each pen cost $1 and each pencil cost 50 cents. How many pens and pencils did you buy? So when we're looking for our variables, first thing we want to do is set up our variables. We're going to look at that final question and see what our goal is. So we're trying to find out how many pens and pencils did we buy. So we're going to let x equal pencils, or I'm sorry, pens, and y equals pencils. So you definitely want to, again, look at that final question and set up your variables to find them. And now it says you bought a total of 6 pens and pencils for $4. Okay, so here we have a couple different things going on. We're told the quantity that we bought, which is 6 total, and we're also told how much they cost. So we're going to set up two different equations, one about the quantity that we bought and one about how much money it cost. And this particular problem, you kind of have to be careful how you read it. This is I bought a total of 6 pens and pencils. So that means you want to read that just like I said it, meaning I bought a total of 6 pens and pencils. So I'm going to say x plus y equals 6. Okay. Now it says I spent $4 on those. So my next equation is going to be all about the money. And I know that they cost a total of $4. Each pen cost $1. So I'm going to say $1 times x, meaning $1 times however many pens I bought. And each pencil costs 50 cents. So I'm going to multiply however many pencils I bought by 0.5. So I can see that my pens cost $1, my pencils cost 50 cents, and I spent a total of $4. So these are my two equations. Okay, I've taken care of all the information I was given. Now when I look at these, I could do substitution. I kind of end up favoring elimination because I'm going to choose to just eliminate those x's by multiplying this top equation by -1. If I do that, I get negative x minus y equals -6. So when I add those two equations, my x's will cancel out. So my x's cancel out. 0.5y minus 1y is going to give me negative 0.5y. So if you think about that, 1/2 minus 1 is going to give you -1/2. And then equals 4 minus 6 is -2. And again, I have negative numbers, which is fine, so I'm going to write that over here for more room. So now I need to get that y by itself, so I'm going to divide by negative 0.5. And if you put that in your calculator, if I say 2 divided by, I'm sorry, -2 divided by negative 0.5, I get 4. So y equals 4, so I have 4 pencils. And when I look back at, I bought a total of 6 pens and pencils. So if I look back at this first equation, then if I plug in 4 for y, I can see where my x is going to equal 2. So I have 4 pencils and 2 pens. Okay. So again, this is another type where we're giving one equation was all about the quantity we had, and one equation was all about the money. Okay. All right, let's move on to the next type. So here we have a youth group of 26 members is going skiing. Each of the 5 chaperones will drive a van or a sedan. A sedan just means like a regular car. The vans can seat 7 people, and the sedans can seat 5 people. Assuming there are no empty seats, how many of each type of vehicle could transport all 31 people to the ski trip in to the ski area in one trip? Okay, so this one has kind of a lot going on also. But let's first look at our last question and see where it says how many of each type of vehicle. So that tells us right away we're going to let x equal vans, because we're looking for types of vehicle, and y will equal sedans. Okay, so here we need to get 26, we need to get 31 people to the ski area. So this question kind of divides up into how many vehicles do we need based on our drivers, and how many people can sit in each van. Okay. So the first equation is about, we know that we only have 5 chaperones who can drive. So we need to know that we can only have 5 vehicles, right? Whether they're vans or sedans, we can't have more than 5 vehicles because we don't have enough drivers. So our first equation is going to be x plus y equals 5. Okay. Our next equation is going to concern how many people can fit in each vehicle. Okay, now this is a little confusing in the fact that when it talks about a van can seat 7 and the sedan can seat 5, that actually includes the driver. So when we're making sure we have seats for everyone, we're going to want to use the fact that we've got 31 total people that need to have a seat. Okay, the drivers need to sit also. So when we're talking about having enough seats, we're going to say the van can seat 7 people. So for every X we have, every van we have, 7 people can fit in that van. And the sedans can seat 5 people. So for every sedan we have, 5 people can sit in there, and we need to make sure we have room for 31 people. Okay? Now, there again, we could use substitution or elimination just to show various ways. I'm going to use elimination. I'm going to use substitution here. So I'm going to take this and just solve it for x, just to show you all different ways to do it. So I'm going to say, oops, x equals 5 minus y. So I just subtracted that y. Now I'm going to substitute this expression in for my x. So I've got 7, 5 minus y plus 5y equals 31. So I just use substitution there into my second equation. Now I've got 35 minus 7y, because I've distributed, plus 5y equals 31. I simplify. Negative 7 plus 5y gives me negative 2y equals 31. I'm going to get my y's by itself, and I get negative 2y equals negative 4. Divide by negative 2, and I get y equals positive 2. So we know we need 2 sedans. And now we can really kind of mentally do the math about if we're having 5 vehicles total and we have 2 sedans, then that means we need 3 vans. Okay? This would be kind of a typical problem you guys might do when you're trying to get rides to some event or something you guys are planning to do with your friends. So there we go. 2 sedans and 3 vans. Okay. All right, let's try a couple more problems here. So these are, let's take a look. This was a shopping one, and this one's a little bit different. So here we're talking about 2 different products, and we're mixing kind of shopping trips almost. Like this kind of talks, I call these like shopping trips. Each trip is going to be its own equation. But you'll see what I mean here in a second. So suppose you bought 8 oranges and 1 grapefruit for a total of $4.60. Later that day, you bought 6 oranges and 3 grapefruits for $4.80. What is the price of each fruit? So again, we look at that last sentence, and we know X is going to be the price of oranges, and we'll let Y equal the price of grapefruit. And now each trip becomes an equation. These actually turn out to be some of the more simple ones. So you bought 8 oranges and 1 grapefruit for $4.60. So we're just going to make one equation out of that sentence and say 8 oranges, 8x, plus 1y, 1 grapefruit, equals $4.60. Second trip, 6 oranges and 3 grapefruits cost $4.80. So 6x plus 3y equals $4.80. Okay, so now we want to solve, and on these I actually do like to use elimination, especially with all the decimals. I just feel like sometimes it makes it easier. I'm just going to multiply this top equation by negative 3. So hopefully you can see there, doing that, I'm going to get these y's to cancel out. Okay? So if I multiply that and bring it down here, I get negative 24x minus 3y equals 460 times 3 is going to give me negative 13.8. When I do the math here, 6 minus 24 gives me negative 18x. The y's cancel, and 480 minus 13.8 gives me negative 9. Now when I divide by negative 18, I get x equals 0.5. So again, x equals 0.5 means 50 cents is the price of oranges. If I plug it in, I'm going to plug it into this first equation up here to find my price of grapefruits. So 8 times 0.5 is, again, just like 8 times a half, so that's going to be 4. I get y equals 0.60. So that means 60 cents grapefruit. So I've got 50-cent oranges and 60-cent grapefruits. Okay. All right, let's do just two more. We're not going to do that very last one. Let's do this next one. So you purchased for $7.52. You purchased 8 pens and highlighters from a local bookstore. Each highlighter costs $1.09. Each pen costs $69. So again, here we're not talking about two different shopping trips. Okay, so it's not like the previous question. We're talking about more like a quantity that we purchased and then the price. So this is going to look more like this one about pens and pencils did. Okay, so again, we're looking for how many pens did you buy? So that means our variables need to be the items, so pens and highlighters. We purchased a total of 8, so x plus y is 8. We spent a total of $7.52. And here you do have to be careful about these, about the order they tell you information in. So be careful, like the way you made your variables over here may not always be the order that they're giving you information. So here we say each highlighter costs $1.09. So that is our y value, 109y, and each pen costs 0.69. Okay. So now, again, let's just kind of alternate. Let's use substitution for this one. So now I'm going to solve for y, and I'm going to get, again, I could have used elimination. That would have been fine too, but I'm just trying to show you all both methods. I'm going to subtract that x over. I get y equals 8 minus x. Now I'm going to substitute 8 minus x when I see a y. So first I'm going to say 0.69x plus 1.09. 8 minus x, 7.52. If you notice, I chose this one to do substitution. If I use substitution on this one, I would have ended up having to divide by decimals and all of that. So that just would have been too much extra work here. If I complete this one, I say 0.69x plus 1.09 times 8. Gives me 872 minus 1.09x. Again, I distributed equals 7.52. I can combine these two. So 0.69 minus 1.09 gives me negative 0.4x plus 872 equals 7.52. I'm going to subtract 8.72. So I get negative 0.4x equals negative $1. I divide by negative 0.4. And 1 divided by 0.4 gives me 2.5. Again, we're talking money, so decimals are fine. So x equals 2.5. Okay, girls, just caught a mistake here. Sorry about that. Obviously, decimals are not okay. We cannot have a half of a pencil or a pen. We're solving for quantity. So if you notice, I kind of sped through this. 7.52 minus 8.72 actually gives me negative 1.2. So I was going a little too fast there, but I realized my answer was not quite right. So this becomes negative 1.2. And then when I take negative 1.2 divided by negative 0.4, I get 3. So that makes much more sense. Again, decimals would have been fine if we were solving for price of pens, but we're solving for quantity. So we had 3 pens, and actually that was the only question they asked us was how many pens did you buy? X was pens. So we've got 3 pens. Okay. Okay, last one we're going to do here. And this one is, again, more of kind of a shopping trip. Last year, a baseball team paid $20 per bat, $12 per glove, spending $10.40. Again, one trip. This year the prices went up to $25 per bat, $16 per glove, and the team spent $13.50. And this says how many bats and gloves did the team purchase each year? So again, we're looking for bats and gloves. And we've got basically shopping trips here. So each equation is going to be a shopping trip. So the first shopping trip they took was they spent $20 per bat and $12 per glove and spent $1,040. Second shopping trip, $25 per bat plus $16 per glove, and they spent $13.50. Okay. So now, again, when I'm looking at this, I'm going to use elimination because I really don't want to divide, and substitution I have to do fractions. But when I look at this, nothing sticks out as being too easy to eliminate at the moment. But if I look at like 20 and 5, let's look at my x values here. I got 20 and 5 that I need to make the same coefficient. I could multiply 1 by 25 and 1 by 20, but that's going to be huge numbers. I also could do 20 and 25 have a common multiple of 100, right? So I'm going to, instead of I'm going to try to make each of them 100. Well, one negative 100, one positive 100. So to make 20 100, I need to multiply it by 5. So I'm going to multiply this entire equation by 5. And to make this equation have an x coefficient of negative 100, I'm going to multiply it by negative 4. So if I multiply 25 times 4, I get 100. I need it to be a negative 100. So if I come over here and do that, I'm going to distribute this 5. So I get 100x plus 60y equals 5 times 1040 gives me 5,200. Then I'm going to multiply this bottom equation by negative 4. So negative 4 times 25 gives me negative 100. 16 times negative 4 gives me negative 64y. And 1350 times negative 4 gives me negative 5,400. So now when I use elimination, these cancel out. I get negative 4y equals negative 200. And I can divide 200 by 4 by negative 4. And I get y equals 50. So that tells me 50 gloves. And I can plug in for my bats. So I'm going to come over here. I'm going to use, go ahead and use this first equation. And I've got 20x plus 12 times 50 equals 1040. 12 times 50 gives me 600. I can subtract 600. I get 20x equals 440. Divide by 20, and I get x equals 22. So we bought 22 bats and 50 gloves. Each year, they just cost a little bit different amount of money for inflation. Okay, all right, we're not going to do that last one. I'll cover that when I see you guys again. Hopefully, I will already be back in class by now, but okay. So this should give you a lot of examples to go with, to take a look back on. Hopefully you followed along on this with your notes. So, and the video's here if you need to watch it again. So at this time, I want you guys to work on the practice applications, these application problems. So you can partner up if you like. You can just work on your own if you prefer that. Some of you can go out in the hall, but if you've got the hall, you need to behave yourselves and be quiet. I want you guys to work through these examples now for the rest of class. And then your homework will be to finish these, the application ones, and then to also do the actual homework. There's only 3 homework problems, so the practice worksheet is part of your homework also. and I will see you guys soon. Bye.